Hi, I'm going to present a paper titled Which Artificial Intelligences Do People Care About Most? A conjoint experiment on moral consideration that I wrote with my co-authors, Jamie Harris and Jacy Reese Anthis. So artificial intelligences increasingly evoke moral responses from humans. For example, people feel empathy for robots being harmed. Some report feeling guilty for causing the chatbot replica's death. People support granting AIs the right to protection from cruel treatment and support granting legal rights to sentient AIs. The level of moral consideration is currently low, but it will plausibly increase as AIs continue to become more advanced. And researchers have found that the extent to which AIs are granted moral consideration is affected by factors such as their degree of autonomy, their physical appearance, and their capacity for emotion expression. An important outstanding question is about the relative effects of these different capacities or features of AIs. Which ones matter more and which ones matter less for moral consideration? And this is important because it will allow us to better understand how people will react morally to AI systems designed in different ways, such as an AI with a high degree of autonomy versus one with a high degree of emotion expression. So we addressed the question of the relative effects of the different features using a conjoint experiment. And this is a methodology that originated in the field of marketing and is increasingly being used in social sciences, including HCI. And conjoint experiments are useful because they allow for the estimation of a relatively large number of variables compared to a typical experiment on a single dependent variable within an experimental design. And a common setup for conjoint experiments involves asking participants to complete tasks in which they make choices between pairs of options. For example, the choice of which of two artificial intelligences they think it's more morally wrong to harm, where the two options vary on different features, such as their degree of autonomy, emotion expression, or their human-like appearance. I'll explain more about the methodology on the next slides, but first, just to briefly mention some points about our sample. So we recruited a sample of US participants from the online platform Prolific, and our final sample consisted of 1,163 participants with a mean age of 43.9, and 50.7% of the sample were men, 47.9% were women, 1.1% were other gender, and 0.3% preferred not to say. So as noted, conjoint experiments allow for a relatively large number of variables to be included in a single experiment. And we included 11 variables or features of AIs in the present study based on a literature review identifying the most common or important features and a pre-testing study asking 30 participants to rate the importance of 24 literature-based features and also the option to add 3 features that were not in the provided list. And we ended up with the 11 features in this table. So autonomy, body or physical appearance, complexity, cooperation, damage avoidance, emotion expression, emotion recognition, intelligence, language, moral judgment, and purpose. And the table also shows how we described or defined the features for participants in the experiment. So, for example, we described autonomy to them as the extent to which an AI behaves autonomously without the need for human control. And the table also shows the levels that we used for each feature. So, for example, we described artificial beings as having autonomy along 3 levels, not at all, somewhat, and to a great extent. And on the right side of the table, you can see that we hypothesized a positive effect for each of the features. So, for example, on the first row, we hypothesized that AIs described as being more autonomous would be granted more moral consideration. And on the second row, we hypothesized that AIs with robot-like or human-like physical bodies would be granted more moral consideration than AIs described as having no physical bodies. So as noted, conjoint experiments ask participants to complete tasks in which they make choices between pairs of options. So here's an example choice task that participants completed. And each participant completed 13 of these choice tasks. So on the left-hand side, we have a table describing two artificial beings that participants were shown. And the first column is a description of the features that the two AIs were described on. And rather than showing every participant all 11 features, we randomly assigned each participant to see 7 of the features to manage cognitive burden. And these 7 features were held fixed for each participant across their choice tasks. In the next 2 columns, we have the feature levels for the two AIs or artificial beings. So for example, in this particular choice task, both artificial beings were described as having autonomy to a great extent, as shown in the first row, intelligence at somewhat, as shown in the second row, and then artificial being 1 was described as behaving on the basis of moral judgments, not at all, whereas artificial being 2 does somewhat, as shown in the third row. And on the right-hand side, we have the choice that participants were asked to make after each task. Which of the two artificial beings do they think it would be more morally wrong for them to harm? And this is how we conceptualized moral consideration in the present study. And because the features shown to participants and their levels are randomized, we can use quite simple statistics to estimate how the features affect how morally wrong people think it is to harm the AIs. So if we code participants' responses with a 1 if the AI is chosen and a 0 if the AI is not chosen, then, for example, to understand the effect of having moral judgment at somewhat compared with not at all, we can look at all the instances where AIs were described as somewhat having moral judgment and calculating the proportion of times they were chosen by taking the average of the 1s and the 0s and comparing that to all the instances where the AIs was described as not at all having moral judgment and calculating the proportion of times it was chosen in the same way. And the difference in these two proportions is the effect of an AI somewhat having moral judgment compared to not at all having moral judgment on the probability that the AI is chosen as being more morally wrong to harm. And there's some additional nuances, like accounting for the fact that participants completed multiple choice tasks, so they're not independent, but that's generally how it works. So on this slide, it's a plot that shows the effect of each feature on moral consideration. On the y-axis, we have each feature and the feature levels. And on the x-axis is the change in probability that an artificial being is chosen as being more morally wrong to harm. And the circles represent the mean estimate, and the bars around the circles represent the confidence intervals. So for each feature, there's a circle that crosses 0% on the x-axis, which represents the baseline level. And then the circles with bars through them represent the effects of each feature relative to the baseline level. I won't go through every feature, but we can see here, for example, that if an AI somewhat behaves on the basis of moral judgments, then the probability they're chosen as being more morally wrong to harm is about 12% higher than an AI that not at all behaves on the basis of moral judgments. And each of the first 10 features in the plot, from autonomy to moral judgment, positively affected moral consideration, as we hypothesized. At the bottom of the plot, the effects for the purpose feature are shown in the negative direction. And this is because we coded this feature with social companionship as the baseline level. So the negative effects mean that the AIs whose purposes were working for business, entertainment, and science experiments were granted less moral consideration than AIs that had a social purpose. So this is also in line with our hypotheses. And we can see also here some of the strongest effects from having the capacity for moral judgment and for emotion expression to a great extent, which increased the probability that the AI would be chosen as being more morally wrong to harm by 24% and 22% respectively. So the previous slides showed the relative effects of each feature, but we also looked more closely at this and conducted pairwise tests comparing the effect sizes. And this analysis suggested that there were broadly 3 categories of effect sizes. The strongest effects on moral consideration were from moral judgment and emotion expression. Moderately strong effects were from emotion recognition, having human-like physical body, and cooperation. And then weaker effects were from damage avoidance, language, autonomy, purpose, and complexity. And note that we didn't include intelligence in this categorization because we only defined it with two levels, somewhat and to a great extent, because AIs without any intelligence at all seemed incoherent when combined with some of the other features. And because of this different scale, pairwise comparisons with the other features were not possible with intelligence. So a key point from this analysis is that 4 of the top 5 features, moral judgment, emotion expression, emotion recognition, and cooperation, reflect an AI's capacity to interact prosocially with humans. So some discussion points and takeaways. So first, each of the 11 features we tested had an effect on the moral consideration of AIs in the expected direction. The largest effects were from features reflecting an AI's capacity for engaging prosocially with humans and an AI having a human-like physical body. And we suggest in the paper that the former could be the result of the perception that AIs are threatening to humans. So showing that they're not a threat and have the capacity to engage prosocially is key for maximum moral consideration. The latter could be the result of an anthropocentric or in-group bias, but these hypotheses should be tested in future research. So to briefly mention some design implications. So first, because morality is such a key part of human-human interactions, AI designers should implement capacities like prosociality and human-like appearance only when they want to closely mimic human-human interactions with AIs. Second, by encouraging high levels of moral consideration, designing AIs with human-like bodies and prosociality could help solve the problem of people being abusive towards AIs, which can cause expensive damage and be dangerous to bystanders. And third, Schwitzgebel and Gaza argue that we should design AI systems that evoke reactions that reflect their true moral status or how much they matter morally for their own sake. If we build AIs with capacities associated with moral status, such as consciousness or sentience, then we should consider also designing them with human-like bodies, prosociality, or other features that affect moral consideration to facilitate accurate perceptions of the AIs. On the other hand, they argue that if the AIs do not actually have moral status, then building them with consideration-provoking features could result in people wasting resources to benefit AIs that they erroneously think warrant moral consideration. So if they don't actually have moral status, we should be cautious about designing them with such features. So finally, to mention briefly a few limitations of our study and some future directions. First, conjoint experiments estimate people's hypothetical preferences and not their real-world behavior. So future research should test the effects of these features in more concrete scenarios, such as with LLMs, interactive robots, and other multifunctional AI systems. Second, our study conceptualizes moral consideration in terms of how morally wrong people think it is to harm AIs. And while that's a key component of moral consideration, there are other components, such as granting rights to AIs. And this should also be looked into in future research. And third, this study prioritizes breadth over depth. And this means that our operationalizations of some of the features are less nuanced than they would be in a more in-depth study. For example, we operationalized autonomy along a single dimension when it's in fact multi-dimensional. And also we use simple descriptions for the feature levels, such as by measuring most of them on simple 3-point Likert scales from not at all to a great extent. So future research should look more in depth into these features, especially the ones that we found to have the strongest effects. Thank you.